Hey, boys and girls. Hope everybody had a great Labor Day weekend. As you can tell, I was unable to make the Zoom classroom meeting today. I am currently moving into my new house. That's why I couldn't make it. So I apologize. Again, I hope everyone had a great Labor Day weekend. Today we're going to go over the independent dependent variable practice that you should have done in your notebooks. And then we're going to get into the notes that I shared with you. And I want you to listen to this video as I go over them. We're going to be spending the next several days on things that are in these notes. Okay, so please make sure you follow along and write down any questions that you may have. Since I am not there today, it is very important that if you need help, that you sign in tomorrow for office hours. I'm in office hours from 1 o'clock. I'm sorry, not tomorrow, on Wednesday. Make sure you sign up or sign in on Wednesday. That would be September 9th. So Wednesday, September 9th, I will have office hours from 1 o'clock to 1:30, and I may extend that to 2 o'clock if people show up. That would be a great time to come in and ask questions. I know there's a few of you who've been on vacation, who are just logging in, that are struggling with some things. Please take this advantage, take this time to sign in on those office hours and let me help you. Okay? All right, so let's get to independent dependent variable practice. I'm going to go ahead and go full screen on this real quick. So I'm looking at number one. A study was done to find if different tire treads affect the braking distance of a car. So again, independent variable. Independent variable is the variable that is being changed or manipulated in the experiment. So read this sentence. What is being changed? What's being manipulated? So a study was done to find if different tire treads affect the braking distance of a car. So what's being changed? The different tire treads. That's your independent variable. My dependent variable is the braking distance of the car. That's what's being affected or what's being measured. Now, control, you'd have to use the same car, you'd have to use the same tires. Okay, so that would be your control. All right, number two, the time it takes to run a mile depends on the person's running speed. Okay, so independent variable. What is being manipulated? What is being changed? The person's running speed. What's being affected? So that's your independent variable is person's running speed. So that goes there. Now, what's being measured or what's responding to that change? The time it takes to run a mile. So that goes in your dependent variable. Control, well, you'd have to run the exact same mile. Okay, that would be the control. All right, number three, the height of a bean plant depends on the amount of water they receive. So what's being changed in this experiment? What is your independent variable? Independent variable. What is being changed? What is being manipulated? So what is being changed or manipulated in number three? It's the amount of water. Okay? For dependent variable, what is being measured? What is responding to what you're changing? So you're changing the amount of water that they receive. What are you measuring or what's responding to that change? The height of the bean plants. Okay? Now, for control, you'd have to use the same pot, same soil, same type of bean plants. All right. The higher the temperature of the air in the oven, the faster a cake will bake. So what's being changed or manipulated in this experiment? That is your independent variable. The temperature of the air in the oven. That's what's being changed or manipulated. Now, what's responding to that change? So we're changing the temperature of the air in the oven. What is responding to that change? The time the cake it will take the cake to bake. I know it says the faster a cake will bake. You can rephrase that to say the time it will take a cake to bake. Okay. Control. Okay, same oven, same type of cake. Number 5, lemon trees receiving the most water produce the most lemons. Okay, so what are you changing or manipulating in this experiment? Well, you're changing the amount of water. What are you measuring? What is responding to that change? The amount of lemons. So again, you have to rephrase these last few. Okay. So again, what are you changing? The amount of water the trees get. What's responding to that change? Your dependent variable, the amount of lemons. Okay. So that's enough for independent dependent variable practice. Now, what you have left to do on that is an independent dependent variable Google form that's posted in Google Classroom. This is for a grade. So please make sure you take your time, use your notes if you have to, and answer each question. It's all multiple choice, 10 questions. Each question is worth 1 point. So I encourage you to go ahead and just pause the video, get on Google Classroom, and get that done. All right, hopefully you just got done with the independent dependent variable practice Google form that is posted in Google Classroom. Now I'm going to show you the other sheets that you should have gotten today in your notebooks. You should have gotten slide 17, measurement science, 18, 19, 20, 21, 22, and 23. Okay, now notice that I'm going to go over the notes to this point, and then you have practice to do. Okay, so you've got this reading graduated cylinder, you've got this reading metric rulers, and then you've got 5 questions at the end asking you questions about what we covered in the notes. Okay, so please make sure you do that, and that's all you have to do for today on that. But you need to continue to listen because I'm getting ready to go over the notes. All right, start here with the notes. Measurements in science. All right, a standard measurement system is important because it allows scientists to compare data and communicate. Here in the United States, we are the only country in the world that still uses the old English metric system. Okay, so in other words, we measure most times inches, feet, yards, miles. The metric system doesn't. The standard measurement system that most of the world uses, actually all the world uses besides us, is the metric system, and it's much easier. Okay, in order to convert inches to feet to yards, you got to know the conversion. Okay, when you're measuring, if you go and measure uh, liquid volume in the English system, you have to know how many pints are in a quart, how many quarts are in a pint, how many pints in a gallon. Okay, the metric system is just it's a very easy system because it is based on the number 10. Okay, now even though here in the United States we haven't adopted the metric system as our official unit of measurement, when you go into most labs across the country, actually all science labs across the country, they use the metric system. Okay, so again, the metric system is a measurement system based on the number 10. A meter is the basic SI unit for measuring length. Mass is a measure of the amount of matter in an object. And SI, the basic unit of measuring mass, is the gram. And we talked a little bit about this yesterday. Okay, the difference, or not yesterday, but last week. Mass and weight is different. Sometimes people get them confused and think they are the same. Okay, mass is the measure of amount of matter in an object, and weight is the measure of the force of gravity acting on an object. Volume is the amount of space an object or substance takes up, and SI, the basic unit for measuring volume, is the cubic meter. It is also ml. Okay, cubic meter or cubic centimeter is equal to 1 milliliter. And I'll go over this again here in just a second. Don't want to confuse you, but there's 2 types of units used to measure volume in the metric system. Okay, it's cubic centimeter or ml. All right, density. Density is a measure of how much mass is contained in a given volume. Okay. Now, I'm going to skip that other bullet point and go down for the formula for calculating density. To figure out the density of an object, you need to figure out its mass and its volume. Okay. Now, figuring out mass, that's easy. You put it on a scale and it tells you how much mass is in that object. Volume is a little bit different. Okay. Volume is a little bit different. I'm going to go back to volume. If I have a regular shaped object, in other words, a rectangular shaped object, I can measure its length, its width, and its height, and I can figure out its volume. Length times width times height is equal to volume. If I can measure all that. Now, if I have an irregular shaped object, let's say I go outside and I pick up a rock, you cannot measure the length, the width, and height of a rock. Okay? What you have to do there to figure out its volume is put it in a graduated cylinder and see how much water it displaces. So, for example, if I had a graduated cylinder and I put its volume at 10 milliliters, and I put the rock in there, and it raised up to 20 milliliters. Well, my volume of that rock is 10 ml. Okay? It went from 10 milliliters to 20 milliliters. So I know that the rock's volume is 10 ml. Hopefully that makes sense. And again, I'm going over this in this video, and I will talk to you guys on Thursday. Okay, Thursday when we're back together as a class, I'll be back on Zoom. Okay, so density equals mass divided by volume. So let's say I have an object that has the mass of 100 grams, and I have that same object has a volume of 10 ml. Well, 100 grams divided by 10 ml, that would equal 10 grams per ml. That's what the density would be. And again, we'll have more practice with this, and I'll go over more about this later. Okay? All right, measurements in science. When we're looking at the metric system, millimeter, its symbol is mm, its meaning is 1/1000th, and its size is 0.001. Centimeter, its symbol is cm, its meaning is 1/100th, and its size is 0.01. Decimeter, its symbol is dm, its meaning is 1/10th, and its size is 0.10. Meter is 1, its meaning is 1, and its size is 1.0. Decameter, okay, its symbol is DAM, its meaning is 10, its size is 10 meters. Okay. Hectometer is HM, its meaning is 100, and its size is 100 meters. Kilometers is km, its meaning is 1,000, and its size is 1,000 meters. Okay, so meter is the basic unit of measurement for length in the metric system. Okay, if I have a decameter, that means I have 10 meters. If I have a hectometer, I have 100 meters. If I have a kilometer, I have 1,000 meters. Okay, kilo, hecto, deca. Okay, deca is 10, hecto is 100, kilo is 1,000. Deci is 1/10, centi is 1/100th, and milli is 1/1000th. Okay? Okay, so again, what would go in this prefix here? Kilo, right? Kilometer, 1,000. What would go in this? What is 100? Hecto. Hecto would be the prefix, so hectometer. Okay? Come down here. Deci is equal to 1/10, so it'd be 0.10. Centi is 1/100th, so it'd be 0.01. And this would be millimeter. All right, going to go back over some measurements here again. In the metric system, basic unit of gram is used to measure mass. Talked about that just a few minutes ago. In the metric system, basic unit of liter is used to measure liquid volume. Please note 1 cubic centimeter is equal to 1 ml. And I will show you and go over that a little bit more later. So if that confuses you, don't worry. We will go over and rehash all of this again and again and again, okay? In the metric system, the meter is used to measure length. So here I have, down at the bottom, I have a metric ruler. So if I have a line that measures to right here, that would be 1.1 centimeters or 11 millimeters, okay? When you look at a metric ruler, each one of these lines is a millimeter, okay? And if you count, there are 10 millimeters and 1 centimeter, okay? So if I had a line that came out to here, that would be 1.2 centimeters or 12 millimeters. Count, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 millimeters, okay? If I came to this line, that would be 1.3 centimeters or 13 millimeters. If I came to this line, it'd be 1.4 centimeters or 14 millimeters. Again, count backwards and you'll see, okay? Each line represents a millimeter. You get to here, that'd be 14 millimeters or 1.4 centimeters. I get to this line, that'd be 1.5 or 1.5 centimeters or 15 millimeters. To go from a larger unit to a smaller unit, you multiply. To go from a smaller unit to a larger unit, you divide. Or you can use the stair-step method to convert units from smaller to larger and larger to smaller. Okay, so if I had 10 millimeters and I want to know how many centimeters that equaled, okay, 10 millimeters is equal to how many centimeters? Okay, so I'm starting at milli and I'm going to the left one time, so I move my decimal point one time to the left. So 10 millimeters is equal to 1 centimeter. And again, I'll go over this stair step in depth later on. Okay, so don't worry if this confuses you. Again, if I had one meter is equal to how many kilometers? Well, I'm going to the left 1, 2, 3 times. So I put 3 zeros in front of it with a decimal point. So it'd be 0.0001 meters. Okay. How many kilometers are in a meter? Well, I'm going 1, 2, 3 times to the right. So I move my decimal point 1, 2, 3 times to the right. 1,000 kilometers is equal to 1 meter. Okay. So hopefully that makes sense. I'm sorry, I totally got that wrong. Let me go back over that. If I want to know how many 1,000 kilometers equals how many meters, again, I'm going to the right, so I would actually add zeros. So I totally messed that up. Okay, you would add 3 zeros. So 1,000 kilometers is equal to 1 million meters. Okay. Again, what I will do is I'll put problems up on the board and we'll go over it. So if that totally confused you, please do not worry. We will go over it in depth and better later. Alrighty. These are graduated cylinders. So when we read liquid volume, we have to figure out what each mark stands for. Okay? So if I look at this graduated cylinder, I know I got 5. I'm going up by 5s, right? So I count 1, 2, 3, 4, 5. So each one is worth 1. Okay? Now I read the meniscus. That's where the line curves. Okay? So if I look at this graduated cylinder, the water line is at, here's 5, that'd be 6, so that'd be 7. 7 milliliters is what number 1 is equal to. Next one, okay? I'm going up by 10s. So I have to figure out what each mark equals. Well, if I go up by ones, 1, 2, 3, 4. Nope, that's not going to work. Maybe it's by twos. 2, 4, 6, 8, 10. Yes. So each line is worth 2. Okay? 2 milliliters. So I come up here, I got 30, 32. Now this line curves right here. So this is halfway between 32 and 34. So that would be what? What's between 32 and 34? 33. So this would be 33 milliliters. Looking at this graduated cylinder, going up by fives. 1, 2, 3, 4, 5. So each mark is worth 1. I come up here. Well, that's easy. Right on the 20 milliliter mark. So this one is worth 20 milliliters. Coming over to this one. Again, we're going up by twos. 2, 4, 6, 8, 10. I come up here. I got 20, 22, 24. Well, looks like it's halfway between. So this is 26 and 28. So what's between 26 and 28? 27 milliliters. All right, down to number 5. Okay, again, looks like we're going up by twos. Okay, so looks like we're going up by twos. So I got 40, 42, 44, 46. Again, I'm in between 46 and 48. So that would be 47 ml. All right, look at this one. Looks like we're going up by ones. So here's 40, 41, 42, 43, 44, 45. Looks right like we're on the 46 line, so that would be 46 ml. Okay, again, looks like we're going up by ones. I come up here, I'm at 40. Here's 45. Looks like we're at 46 ml. Here, going up by ones again. So I'm at 10. 1 past 10 is 11, so that'd be 10 ml. All right, now, again, if you want to find the volume of irregular placed object or irregular shaped objects. In other words, you can't take a measuring tape or you can't take a ruler to nail and figure out its length, width, and height to figure out its volume. Okay? So what you got to do is put it in water and see how much water it displaced. Okay? So for example, if this nail was at 5 ml and it jumped up to, well, here's where it was at. Okay? So each one of these, you can figure out the volume of each one, okay? So if I'm at 10 ml and I put a nail in and it goes up to 11 ml, what is the volume of the nail? 1, right? It went from 10 to 11. So the nail is 1 ml. I put a key in. I went from 11 to 14. So what is the volume of my key? 3 ml. I put a glue stick in. I went from 11 all the way up to 19 ml. So what is the volume of the glue stick? 8 ml. Because again, I went from 11 to 19, so the glue stick has a volume of 8 ml. The button, if I went from 10 or 11 ml to, that's 11, 12, 13 ml, then the button has the volume of 2 milliliters, ml. That's what ml stands for. So which object had the greatest volume? That'd be the glue stick. Which one had the least volume? That would be the nail because it only went up 1 ml or 1 milliliter. Okay, we'll go over density later. We'll review here the metric system is based on what number? 10. What is the basic unit of length in the metric system? That is meter. What is the scientific measurement for area? Don't worry about that one. Skip that one. What is the basic unit of capacity in metric system? It's cubic centimeter or ml, milliliter. What's the basic unit of mass in the metric system? It is gram. And the definition of mass is the amount of matter found in an object. Kilo is equal to 1,000. Hecto is equal to 100. Deca is 10. Basic unit is 1. Deci is 0.10. Centi is 0.01. And milli is 0.001. Okay. Here's the stair-step method again for figuring out metric conversions. We'll do these problems later. I don't want to confuse you. Okay. All right. So what do you got left after the notes? I kind of talked about this a second ago. Okay. You're going to go back. Okay. All these notes I just went over is right here in your science notebook. Okay. Now I want you to use your notes. Tell me, what is the liquid volume of each one of these graduated cylinders? Put the answer down here in your science notebook. Go to slide 22. You're going to read the length of the green line for each metric ruler and tell me what the measurement is. Please don't forget your units. And then answer these 5 questions. In the metric system, what unit is used to measure mass? Okay, type out the answer. In the metric system, what unit is used to measure length? Type out the answer. What is the formula for calculating density? Type out the answer. 4, you have an object that has a mass of 100 grams and the volume of 20 centimeters cubed. What is the density? Okay, so what is the formula for density? Mass divided by volume. Okay, so if I take mass of 100 divided by 20, I'm going to get, you ready? I'll do this one for you. 5. This is how you write it. 5 cm 5 grams per cubic centimeters. Now, you can just write CM3 like that if you want, or if you know how to do subscript, you go up to format, you hit text, you hit superscript, and that puts the 3 above it. Okay? All right, so I just gave you 2 answers right there. That's what type of great science teacher I am. You should feel lucky to have me. All right. All right. Just kidding. Just messing around. Anyways, boys and girls, that's it for today. You are, again, on Wednesday, we are not in class. So this is a great day to get caught up on everything. Check progress book. If you're missing any assignments, get those turned in. Okay. What should be turned in right now is mystery footprints. Okay. The time for accepting that is coming to an end. And the 3-hole bottle lab where you did the Google form. Those 2 things need to be turned in. And then you got another assignment today doing variable practice, okay, identifying the independent and dependent variables. All right. So you got Wednesday to get caught up on that. I will see you guys on Thursday. Have a great rest of your day. And again, if you need help, please stop in on Wednesday office hours, 1 to 1:30. Take care. Bye.